Everyone, this is Dr. Demi. I hope you are doing great. Welcome back. For those of you who are stumbling on my videos, this is a Cambridge A-level biology channel, and it has all the content that you need to study for the exams from chapter 1 to chapter 19 in very easy, digestible bits that I believe you will find very useful. I have a workbook that I have put up on sale, and at the moment I've actually put it up as what you can afford, but I only made a few copies available for that, so if you're lucky you can still grab it. This is just trying to change my recording here. Okay. So yeah, this is what the workbook looks like. This is what you would find if you go on Gumroad. The link is on the channel, and I believe it is linked under this video as well. So if you're still lucky, you might find it for a pay what you can option. But if you're not, then you would have to pay the full price, which is what it will bounce back to once this promo is over. My ultimate hope is that you use the workbook to guide yourself as you study, and that before you watch this video that you attempt the problems in the workbook so that you can score yourself and see how well you have done. Okay, so this is for chapter 2, so I'm not going to go into detail because again a lot of these things have been covered in the topics that I already did on the channel, and you can just go to playlists, and when you go to playlist you will be able to find all the videos by chapter. So just starting with revisions of definitions. What is a monomer? And you know that monomers are repeating subunits, so they're basically the starting units in order to form something bigger. And I think in biological molecules in the video I used the description of a brick wall and the little bricks that make them up together. So the little bricks, or just the single bricks rather, would be the monomers, and if you put many of them together you can make a wall. And a macromolecule is basically a giant molecule that is formed from the combination of monomers and sometimes from the combination of polymers as well. Then I asked you to put in the building blocks of biological molecules, and hopefully you get this right. So you know that carbohydrates are built from monosaccharides, proteins are built from amino acids, and to make a lipid you need fatty acids and glycerol. In order for you to form a polymer from many monomers, you need condensation reactions. And the condensation reaction is basically a reaction where water is released. And in order to break down a polymer, in order to form monomers, you will use a hydrolysis reaction, which is basically the addition of water. Then we got to some interesting exercises where I told you to identify some structures, and again this is just to get you used to what you might see in the exams, because sometimes in the exams they don't tell you what the structure is, but they just show you the image and might ask you what it is. So you should be able to tell by now, if you've been studying bio, that alpha glucose has its hydroxyl group at the bottom of carbon number 1. So on glucose, this is carbon number 1, this is carbon number 2, that's carbon number 3. Basically the edges of these compounds of these structures rather, are where the carbons are. So those are your 6 carbons. On carbon number 1 for alpha glucose, the hydroxyl group is at the bottom, and for beta glucose it is at the top. That is how you can tell the difference between the both of them. This is fructose. I'm going to fructose before galactose because I want to say something about galactose. So with fructose, I always tell students to imagine that this is like those, you know, those funny houses you draw when you're young, where like someone says, oh, draw me a house, and then you draw something that looks like this, and then you put a door. Well, I know you guys are a bit more sophisticated these days, but this is how I used to draw houses when I was a child, and now that I look at it, it's like I'm drawing a very scary mask. But basically, if you think of this top part of this very dodgy looking house, you can imagine this top part of the molecule to be that. This is how I identify glucose. I immediately, when I identify fructose rather, I immediately think of this house and I say, oh, if I'm seeing this structure, then I must be looking at fructose. With galactose, it is a bit difficult because galactose has the exact same formula as glucose, so it can be a bit difficult to tell apart. But what you'll find most of the time is that they move the CH2OH group here to the bottom, rather than putting it on top where you would find it with glucose. So that's something that might be able to help you tell it apart. Okay, then we continued with some identification. So when you have two glucose molecules, because these are two glucose molecules, what kind of molecules have you formed? That would be maltose. So maltose is a disaccharide made from two glucose molecules. Sucrose is a disaccharide made from glucose, which is this one, and fructose. Remember the roof of the house I spoke to you about? Yeah. So sucrose is made from glucose and fructose, and it's also a disaccharide. And again, I mean, I ask you here, so a lot of the questions in the workbook are to just help you reinforce concepts, okay? I also have notes in there. I mean, I'm sure those of you will have the workbook. You're glad to see things like, you know, how to test for lipids and all of these things that you need to know, and like fractionation experiments, those kinds of things. So, but the point of it is to reinforce what you've already learned and to enable you recall your information with ease, as well as I guess, be able to apply it. And not, I hope you can apply the information that you're learning when you're asked the question that's not exactly like, oh, tell us if this is glucose, but you're able to think through this properly. So what type of carbohydrates are in E and F? These are E and F, by the way. That would be a disaccharide. And right at the beginning, when we saw glucose, fructose, those are all monosaccharides. Okay. And then I asked you here to name the bond that has been labeled in this figure. And this was the arrow I put there. And the reason why I ask you this is that I see that a lot of students still struggle to remember which bonds go for what. So whenever you're thinking of carbohydrates, always think of a glycosidic bond. And the easiest way to remember that is to think of the word glyco already meaning something to do with a carbohydrate. Think of glycogen, glucogenesis. Like it just gives that, it lends that, should I say, that sense of something that has to do with glucose. So always think of that, and that will help you remember that whatever bond you see between carbohydrates, this oxygen here is the glycosidic bond. All right. And then I ask you, what is the monomer of cellulose? Cellulose is made from beta glucose, because beta glucose, well, cellulose is the only macromolecule that's made from beta glucose at this level that you need to know about. Then I ask you, what's the difference between amylose and amylopectin? Again, please watch all the videos I've done covering all of these things, because all of these have been explained, so I'm not going to go into any detail. Again, if you're new to the channel, just go to playlists, and if you click playlist, you will see everything by chapter. You should be able to access them with ease. Amylose is a straight chain polysaccharide. It has alpha 1,4 glycosidic bonds, while amylopectin has both alpha 1,4 glycosidic bonds and alpha 1,6 glycosidic bonds. This is not how you spell both. That was an error, so please don't put an E behind your both. It should be BOTH. Okay. What is the general formula for carbohydrates? This is it. It's CnH2ON. So in other words, if N is 3, okay, then your carbohydrate will be C3H. So remember, it's H2O times N. So you already know that O is also going to be 3, because you can just assume that there's a 1 here. So 3 times 1 is 3. So O is going to be 3 and H is going to be 6. So whatever number of carbons you have will tell you how much hydrogen and oxygen you should have. So this is the formula that you would use to figure out what a carbohydrate formula is. But then the next question is something that I think many students stumble when they come across, and that's because they forget a crucial aspect of it. So it says, what's the chemical formula of a maltose molecule? We just said in an earlier slide that maltose is made from 2 glucose molecules. We know that glucose is C6H12O6. And if there are 2 of it, then it means that we will have C12, because it would be times 2, right? It would be C12, H24, and O12. And again, this is because maltose has 2 glucose molecules. But this is not the right answer. And the reason for that is you need to remember that when you join 2 glucose molecules together, you're going to lose a water molecule, so minus H2O. Okay, so if you remove 2 hydrogens from here, you're going to be left with H22. Okay, because you've removed 2 hydrogens, and if you remove 1 oxygen, you're going to be left with you're going to be left with 11. So this is the right formula for maltose. If you were checking, for example, for a trisaccharide, which is a saccharide or a sugar that has 3 monomers in it, then you would have 2 condensation reactions, because remember, it would be, let's say it was 3 glucose molecules, it would be glucose number 1 forming to glucose number 2, right? So this gives us minus H2O here, because that's 1 condensation reaction. And then we have another glucose molecule, and that's another minus H2O, because this is another condensation reaction. So if you wanted to figure out the formula for this, you would not only remove 1 H2O, you would have to remove 2 H2Os, or if we wanted to make it easier, you would have to remove H4O2 from whatever the total of this should be before you can get the right formula. So please, please don't make this mistake in the exam. Make sure you remember that there's a reaction that has taken place and has caused the loss of water, and that water has to be deducted from the final formula of the molecule that you have formed. All right. Then I have a question here on, I'm just going to erase all of this. I have a question here on comparing glycogen and starch. And I think the big thing I want to say, I'm just going to leave that for you to read through, because again, I've explained a lot of these things in the videos on the chapters, so you can just go watch those videos again if you feel like you're a bit stuck. What I want to just point out here is that whenever you see a question that says compare, compare means that you state both the differences and the similarities between the two things you are being asked to compare. So most people, when they see compare, they tend to think of, oh, I need to only talk about the differences. It means also talk about the similarities, all right? So for example, compare Dr. Demi to maybe Dr. Sarah. Then you might say something like, oh, they're both doctors. However, the difference is Dr. Sarah is a medical doctor and Dr. Demi is a doctor of philosophy, right? So those are things that you need to make sure that you're putting out whenever you're doing a comparison. Don't only focus on the differences. The last question here on the slide is, which other carbohydrate is similar to glycogen? And that is amylopectin. So amylopectin is what makes up starch. Starch is equal to amylose plus amylopectin. All right. And like we said earlier, amylopectin is a branched molecule, not necessarily highly branched, but it's a branched molecule because it has alpha 1,4 and alpha 1,6 glycosidic bonds. Glycogen is exactly like that. It also has alpha 1,4 and alpha 1,6 glycosidic bonds, but it has more alpha 1,6 glycosidic bonds than amylopectin, so it has a lot more branches. And if that just flew over your head, please watch the videos I have on biological molecules. All right, then I have exercises on lipids, and I asked what are the components of a fatty acid. It's usually a hydrocarbon chain and a carboxyl group at the end. What's the difference between a monounsaturated fatty acid and a polyunsaturated fatty acid? What you need to bear in mind, the basic understanding you need to have here is that when I say it's unsaturated, and this is a chemistry term, it means that there are double bonds in the compound. So monounsaturated means one double bond, and polyunsaturated would mean many double bonds. Like carbohydrates, whenever you put lipids together, or whenever they react with alcohol, for example, what you will form is an ester bond, okay? And here I ask you to show how a triglyceride is formed. I admit I've become a bit lazy, so I took this directly from the Cambridge textbook that I've been telling you all I use. But I understand that it's important for you to be able to know how to draw this. So first of all, always remember that your glycogen, sorry, my pen sometimes gives me problems. Or is not glycogen, sorry, your alcohol that you react a fatty acid with is usually glycerol. Okay. It's usually glycerol. So you need to know how to draw glycerol, and that's exactly what I'm doing here. Glycerol has 3 hydroxyl groups. Okay, because each carbon on glycerol has 1 hydroxyl group. And what glycerol does is that it reacts with the carboxyl group of the fatty acid. All right, so this is the carboxyl group. If you write out the carboxyl group, it's COOH. So it reacts with that. I'm not going to draw out the entire carboxyl group for these ones because what I want to show you is actually here. So it reacts with that, and if you notice here, we have OH on one side and we have OH on the other side. What's going to happen, I see I made a bit of an error here. I'm just going to write it as OH. So what typically happens in this case is that you will have your H2O, right? So this is a OH here. To form H2O, you just need to absorb H from there as well. So in this case, you will have 3 H2Os that are released. And the bonds that will be formed would then be these oxygen bonds over here. So very similar to the glycosidic bond. It would be oxygen bonds and, well, not oxygen bonds in terms of oxygen bonds, but I'm saying the oxygen represents the bond, and that becomes your ester bond, okay? So that is how you form the relationship between glycerol and a fatty acid. And always remember, it's 3 condensation reactions, so you release 3 molecules of water in order to form a triglyceride. Why is it called a triglyceride? Because it has 3 fatty acid tails attached to it. And here you have compared the structures of triglycerides and phospholipids. So again, I'm not going to read through that because it's all in the biological molecules playlist. But always remember that with triglycerides, you're dealing with 3, and like the name suggests, tri. And with phospholipids, you're dealing with something that has a phosphate head and fatty acid tails. So the similarity here would be that, yes, they both have fatty acid chains attached to them, but the differences are what I have stated here, in the sense that triglycerides have 3 of those fatty acid chains, while phospholipids only have 2. And phospholipids tend to have a hydrophilic phosphate head. So what do we use triglycerides for? By the way, triglycerides are in our bodies. There's no, some people say, well, I don't eat fat because I'm trying not to get fat. Fat does play a role in your body in terms of like serving as an energy reserve. So if you're able to go the whole day without eating breakfast and you only eat at lunch, what your body is doing is it's breaking down whatever fat reserve in order to give you energy. They can also be a metabolic source of water, and they insulate against heat loss. So the more fat you have in your body, the less likely you are to get cold in, well, I guess in mild conditions. But that doesn't mean you won't get cold. A lot of people still get cold, but just saying that it does insulate you against heat loss within your body. Okay, this slide came out quite small, but I hope you can see it. But the question, I'll read that out, is what is the bond formed between 2 amino acids? So this is the protein section of the chapter, and that bond is peptide bonds. When 2 amino acids are joined by a bond, what is that structure called? It is called a dipeptide. And when you have a chain of amino acids, you have what we call a polypeptide. So again, these are just revisions to help you think, to not help you think, but to reinforce what you already know so that you can think through problems with ease. Here it says to draw the general structure of an amino acid. I've done this so many times. I hope you all know the way it goes now. So we start off with carbo on this side, and that's the carboxylic group. And this is amine on the other side, and that's the amine group. Okay, and they have a carbon between them, and that carbon we say is because it's a diamond ring. Diamond rings are pressurized carbon actually. And then they have a pastor, imam, a friend, whoever who has joined them together. And then there is a side group, which I don't want to encourage, but it's just an extra person in their relationship, if you want to put it that way. This is the structure of an amino acid, plain and simple, right? Then here I put this table in the workbook because I really wanted you to make sure you're aware of what breaks the different bonds. And the reason for that is I've seen questions in multiple choice papers like paper 1, and sometimes in paper 2, and even sometimes during the paper 3 experiments, because some of the experiments covered biological molecules where you're required to have this information. So I'm not going to read through the whole thing because again most of this has been covered in the biological molecules playlist, but I do want you to take note of the fact that you can break peptide bonds by adding water. You can break hydrogen bonds by adding heat. To break ionic bonds in the tertiary structure, you change the pH. To break a disulfide bond, you use reducing agents. And to break hydrophobic interactions, you use organic solvents. The one thing I want to point out here is that with the quaternary structure of a protein, you're not really speaking of a structure per se. You're looking at the number of polypeptide chains in that protein. So if it has 2 or more polypeptide chains, then it is considered a quaternary structure. And a quaternary structure has all the bonds that you would typically find in a tertiary structure. That's the one thing I want you to note. The second thing I want you to note is that there are hydrogen bonds in the tertiary structure, like I said here, but I haven't written it down here on this side to say what breaks a hydrogen bond because that has already been covered in secondary structure. So just when you're taking note of this, just bear that in mind, okay? All right, then this question says show the combination of the 2 amino acids below and label the bond. So always remember, always read the question completely, and I'll just show you how to do this very quickly. So the best thing to do is to take your amino acid that's on the left. All right, you start with the one on the left. That's if you write from left to right like I do, because I know in some places you write from right to left. So you take this amino acid and you basically just copy what you have in the question. Well, except for this, you don't need to copy the name. It gets interesting. This is where you start to make changes because you're trying to merge these 2 groups with each other, okay? And what you're trying to extract from them is H2O, because remember, this is a condensation reaction. So we already have our OH and we have our H over here, and that gives us H2O. All right, so we have I'm just going to erase the bigger one and do a circle with a blue line, I think. So here, that's our H2O. Okay, once we take those off, then we have this carboxyl group, which I have represented here, and then we draw a line and we have our N, which is this one, and H. And notice you don't slant them to the sides anymore because now they don't, like, you can't do that because you've taken off the water, so you can just place it straight on top, and then you just copy the rest of the other amino acid. And please don't do what I'm doing right now, like, which is writing outside the box. If you are given a box in CIE, please make sure you keep your answers within the box. It's just my pen and my orientation after a long day of work is not too great. Okay, so now we've drawn it out to the best of my ability at least, and then it says to label the bond. The bond is where you have the combination of the carboxyl group and the amine group. So the carboxyl group of amino acid A and the amine group of amino acid B, and that's this. So peptide bond. So you label it. You don't need to put an arrow when you label, and you use a ruler for your label as well, so you write peptide bond. But there's something else that's missing from here. We removed water, all right? We removed H2O, so you must write that as well, all right? Because it says show the combination. So even though you've already shown that when these 2 combine, this is what they look like, you still don't have a complete chemical reaction if you don't show that water was released, all right? And then, yeah, what kind of question is, and what kind of reaction is it? It's a condensation reaction. In addition to the combined structure, what other molecule is formed? It's water. And then there's a structure about hemoglobin. Why is hemoglobin referred to as globular while collagen is a fibrous protein? And again, please watch the videos I've done, but hemoglobin is like a ball shape, right? It has all its hydrophobic amino acids on the inside, and it's hydrophilic amino acids on the outside. Collagen, on the other hand, is arranged in bundles of fiber. So you might you see it as like fibrous proteins, right? It's like having broomsticks standing like right next to each other and being held together. Broomsticks is probably not the best example I can come up with, but it's been a very long day. So I'm a bit tired. How is the structure of hemoglobin related to its function? Again, because it has its hydrophobic groups on the inside and the hydrophilic ones on the outside, it means that it can easily move around in the blood because the blood is hydrophilic. The blood has water in it, and that enables it to transport oxygen around the body with ease. Then the last section is water a polar molecule? Yes, water is polar, and what we mean by polar is that it has partially negative and partially positive sides. Excuse me. What characteristic of water is responsible for maintaining the internal temperature of cells? That's called a high specific heat capacity, which basically suggests that in order for you to raise the temperature of water, you need to put in a lot of energy. And it also has a high latent heat of vaporization, which again is, in order to vaporize water, you need to put in a lot of energy. And because water has that, it means that to change water from liquid to gas, you have to take energy from the surrounding environment and put it into the water molecules so that they can break apart and become gaseous. Now, when you take energy from the environment, it means you remove heat from the environment. And for that reason, the environment can become cooler than what it was before. So that sort of allows, it's an important characteristic because it allows people like us to cool down. So for example, if you're very sweaty, you might be irritable, but if you were to get into a place where there's a fan or something where the temperature is a little bit, I don't know, cooler, your sweat starts to evaporate and you feel a lot better. So that's what that's basically about. So yeah, that's the end of chapter 2. I hope you have found that helpful. Again, you can get a copy of the workbook on Gumroad, or you can get it on Amazon. Gumroad is a lot easier for you to just do a transaction and to get the workbook. So I hope that, yeah, that it works out, and I hope all of you are excited for your exams. I am trying to complete all the chapters for the workbook before, I'm trying to get it done before June. I hope I can. And I'm not going to be on the channel frequently. I've gotten a lot of requests from students saying, oh, please do paper 3. Please go to the playlist that says solutions to past papers, and you'll find that I've already covered a couple of paper 3 papers, and they already have everything that you need to know. So check those out and you should be good. All right, everyone, have a good night. Bye.